Alright, welcome back. We are doing the stream again. Looks like we're live on all the usual platforms. Got Diode Zone, YouTube, Twitch. Oh, and Tuco's walking around my desk. Tuco, are you gonna stay put for the camera? You know the answer is no. Hop. Dude, where do you want to be? Welcome back to the stream. This is going to be another chill kind of programming stream, continuation of this granular synthesizer project. And the project is mostly C++, although we might work on some of the Python parts today. I was focusing on kind of changing up the file format that it uses to store its grain database, since that's one of the more foundational layers of the software that I want to get, kind of firmed up sooner. Oh, I guess he is leaving. I've had a few different formats I've used for that so far. I have been experimenting with this stuff in Python using Jupyter Lab, aka IPython notebooks. Between streams, I moved a lot of that Python code to some more standalone Python tools in this project. And I'm trying to change up the file format. I went from everything in numeric Python arrays, which was kind of bad for the audio data because it's uncompressed, to JSON for all the index information and then a FLAC file for the audio, which is okay, but not great. Multiple files, kind of inconvenient, and JSON is not great for some of the larger data tables. So then the current format is more like a zip container that then has a few different things in it. It can have the audio in FLAC. You could use other formats. FLAC was just convenient for this. And then I can have just a compressed binary table for some of this other grain data. And I can still use JSON for whatever I feel like. I think trying to watch the Diode Zone stream on the chat laptop might have overloaded the chat laptop. So what do I have? Got a to-do list that probably needs some updating. Did a few test runs on this Python tool just to see how it's working so far. There's some of the outputs so far. I've been giving them a custom file extension, but they're really just zip files with JSON, FLAC, and a binary array. And I've got a couple of outputs so far using the latest generation of the script. These intermediate files in NPZ format are in the same format, but I've also been trying to regenerate them using the latest version of the script just to make sure I didn't break the script. One thing that I might do is work on the script that goes from the numeric Python arrays to this zip file format, since that tool really does not need to be slow, but currently it's very slow. Two goes back. I noticed something that might be a quick fix that wasn't on this list, but I was just trying this out before the stream. I started throwing some asserts I hadn't seen before. Ah, this one. Yeah, so this shows up when there's no grain data loaded. It seems to be, I mean, I'm assuming this is coming from the background thread that's trying to render the image that would go here. And so instead of not rendering the image, which is probably what it should do, or rendering a blank image, it's very slowly printing lots of error messages. So I assume this is like not a number or something coming out of the floating point calculations, but let's just check what this error is actually referring to. Oh. Is this used internally in the contrasting color code, maybe? This would assert if somebody tried to make a color with not a number in the alpha channel. I could just make this easy and get an actual stack trace. Actually, I think it'll just trap on the assert. I've done some stuff I don't actually need it to stop on. Yeah, okay, that's not actually that helpful. Yeah, okay, that was a bit of a leap of faith since that could have been called from a ton of places, but the one that actually had symbols that we found in LLDB were in our code, so we got this, which seems to be the stack trace we actually wanted. I mean, it's very similar, so this is in the application initialization, but this path through contrasting is probably what we're hitting, since contrasting is in the inner loop in that background thread. So yeah, let's just go to that code. Yeah, so if there's that num samples, so we do actually have to make sure we have a non-zero num samples before we can compute any of this. So we actually have to do that check while we still have the grain data accessor. That's where we take the read log for this data. If we checked in the caller to render image, then that would introduce a race condition where someone could change the grain data in between our check and this code, and we would still end up with the not a number, which wouldn't crash it, but it would generate all these asserts. So the clean way to do this is probably to have this be allowed to return a null pointer, which we don't have to write anything special because this type already allows nulls. But after taking the grain data accessor lock, we'd have to actually check. So we'd have to move this so that we allocate the image after taking the lock. Oops. And just return null if we might as well check for number of bins and number of grains also, but num samples is the one that would actually cause a problem immediately. Now I'm thinking about what happens if num samples is fine, but we have 0 bins or 0 grains. All of that, I think those failures happen inside point info, and I think we've already accounted for those. I mean, so for the bounds to be able to contain a point, it's going to have non-zero height. I think the other edge cases are handled inside grain data accessor, actually. So that's fine. Let's take the accessor first. Yeah, I mean, if we're gonna, we already are allowed to have null images here because that's the state when the image hasn't been calculated yet, and so we might as well use that for all the weird edge cases like 0 sizes. What type are those even? Those are all nice unsigned. The tablet I'm doing chat on might have slightly crashed. Sorry if you're trying to get my attention. I mean, a little sorry. Like when the computer is behaving as if the network connection is completely dead, but it's actually a software problem. It's like the kernel ran out of internet fluid or something. Oh, there's a request for context about the project. Basically just trying to make a granular synthesis kind of thing and making, it's like baby's first audio plugin sort of, but it's taking a large database of input audio, which in this case I'm using mostly stuff from the TikTok text-to-speech voice, but I've also been trying a few other things. And then the main gimmick here is it's a large database of sample data that is sorted by pitch and then sorted in some other ways additionally. And then a tool that can play that back in real time, assuming you have a fast SSD with the dataset. So if you look at the first stream in this series, I have some example audio that I made using some stuff that takes a while to run, written in Python. And it's kind of entertaining. It's, it's like not stuff that has a lot of like mixing or creative control at this point, because it's something where you have to tweak a parameter and then wait an hour to get some audio. But it seemed interesting enough to where I'd want to maybe try writing some C++ code to make it faster. Okay, cool. So this is no longer doing anything inappropriate when it's not loaded. This is still expecting the old format, which is JSON and then a FLAC file alongside that. So this size is just the size of the JSON index. The actual FLAC data is on the order of, I'd say, like 3,000 times larger than these files. And that's alongside. So let's open one of these big ones. This takes a sec. That's mostly parsing the JSON. Then it takes another sec to load the image. On the last stream, most of that ended up being making that image renderer run asynchronously in the background. Keep accidentally turning on this feature that doesn't work at all with this monitor layout. Yeah, so resizing is less horrible now. You can resize it, and it's approximately as bad as resizing usually is with Juice on Linux, in my experience. Doesn't seem to be worse for this application. You might notice it's a little blurry at first, and then in a sec it should crisp up. Might not be able to tell the difference from where I'm looking at it. We should be able to take a close look at this actually and see the super sampling improvement. Gosh, is there a more convenient way to zoom in to just a little part of the screen? I was trying the accessibility zoom, but that wasn't quite what I want in this case. This looks like the low-res version still. Imagining things? Let's try a more extreme difference. Oh, maybe now it's calculated. It looks a little sharper now. It's going to be extremely slow right now because this is a debug build. And some of this code is just the kind of, the kind of C++ code, right, where it's got enough layers of abstraction that touch the inner loops to where the debug layers are just or the debug builds are just super painful to use. I think that might be what we're dealing with this image renderer. Anyway, it should be more obvious if we're actually switching between input files. Oops. Okay, so there's another input. So there's an obviously much lower resolution that just clicked into improvement. So that's useful. Let's try to go to the larger input file. Yeah, so that first long delay was loading the whatever 30 megabytes of JSON. That we're going to take care of with this new file format that's mostly binary. And then it pretty quickly gave us this low-res rendering. And then I think just now that was the high-res rendering coming back. So that's reasonable for a debug build, I think. I'm not covering any new ground here. I'm just trying to kind of check assumptions. Let's look at a screenshot of this. This is kind of what I'm going for, right? Like, it looks like a bunch of tiny anti-aliased rectangles, not like a low-resolution bitmap that's been bilinear interpolated. There's a little bit of noise from the random super sampling, which I could get rid of in a number of ways, but I kind of like how it adds a bit of texture to the graph. Okay. And it's also trying to produce audio. I just don't have that connected right now. Oh, this is one of the large files, so it might be hitting that 2 gig limit problem. Oh, now it's definitely playing. I just have the monitor on too low.
塩しのりちシークワーサー太し方法だく祭る学生ジンベエサメの劇水素の染色体アメガシ
So this isn't with any kind of proper granular synthesizer. I'm just testing the storage layer by seeking around. You can hear the pitch change as I sweep back and forth.
Strafe.
Vase affirms. Shadowy gigabit variegate evasion depopulates petrologists.
Partners comprehends counter-rated.
Stimulated movie goer.
Lies trisected handcuff. Not questioning immolating squeamishness.
Gesiedelt zu Lunch as
Little cakes peels. Healthful. Näherungsweise munkelt, inwieweit J8 Handelnshochen neuen Ho sie Pinzern
Oh, this one's really small.
It's
really hard to tell which one's which right now because they all have terrible generic names, which the new tool should also fix. Yeah, this one's a nice big chunky database. 10-second wide grains. 1,700,000 of them. Already crashed. Okay, this is 311.
Als Freitagmorgens zurückgekommen.
If I stay at the very beginning of this file before 2 gigabytes, it won't crash. Oh, I strayed past 2 gigabytes. Yeah, that's certainly something I want to debug soon. It's going to interact with the storage layer though, so I'm going to swap that in. So it loads zip files first. Oh, we have some good cat time, huh?
Auch im Unteren Noden der
Yeah, here, I mean, you can see that I'm not paying attention to grain boundaries or anything. I'm just skipping from one to the next abruptly. Okay. Just make the terminal really small and the cat really big. Is that too much? What does this say there? Changes. Oh, different directory. Also some easy diversions, like we could do this color scheme. I think I decided I don't care that much about plots. I was going to add PDF output alongside using the same matplotlib kind of things that I was doing in the notebook. But I'm not too enthusiastic about having it produce like multiple side-by-side output files now that I've got this zip container thing happening. So I think I'd rather just save the plots for a separate tool if I even want them at all. But we've got that real-time-ish graph in the C++ code now, so there's like less and less I actually would want those plots for. So did most of this. I've just kind of moved that code over to this project and added some command line options for the IPython code. Cleaned it up slightly, but it's still, as far as algorithmic efficiency, pretty terrible. So I've still got the work divided into these two steps. There's one that I'm calling scan and one that's pack. So scan will take a big batch of WAV files or MP3 files or whatever, and it will just in parallel run a bunch of separate jobs on those files to do pitch detection. And then it'll combine the output from those parallel jobs into a big database that goes into a numeric Python zipped array file, or NPZ. It's not efficient. There's a bunch of room for improvement, but it's also pretty parallelizable because it works on all the input files separately, and the input files, at least with the TikTok data set, are like 20 or 30 seconds each. Whereas I also did some radio recordings just to try this on like talk radio or whatever, and some of those are hours long, and the pitch detector seems to use tons of memory in that case, so it would be worth maybe applying a different strategy for those, but mostly I'm dealing with these small files that it seems to handle just fine. So I'm tempted to leave this tool somewhat alone and just let it chew up CPU for a while. This is most of what it's doing, is calling this librosa probabilistic yin detector. Just running that a bunch. Librosa.load can also optionally do sample rate conversion, although I'm trying not to do that in this case. So I think that's probably fine for now. This other pack script is a bit more of a problem though. The main thing this does is it takes a bunch of data and throws out as much of it as possible, and then gives you a compressed output file or whatever's left. So the idea is that you would run that pre-analysis step on a bunch of data in bulk and just let that take a while, and then you would kind of mix and blend those result files to your taste and generate something that has about the right characteristics, and you would use this pack tool to do that. And it doesn't really need to be that slow. Like, it needs to copy gigabytes and gigabytes of data and lightly compress it. But right now it's ridiculously slow, and it uses like literally hundreds of gigabytes of RAM. Well, hundreds of gigabytes of swap space and all the RAM I can give it. Yeah, this is very slightly cleaned up from the IPython code. So far, it's mostly good. Like, we're opening the input files, building this thing that I'm calling a combined grain index, which is just a few parallel arrays with the center frequency, or the fundamental frequency, the grain location, and the input number for all the grains. It's pretty straightforward. This is also where I'm discarding grains on boundaries, since that's a convenient place to do it. Like, after this point, I'm dealing with kind of one big index rather than separate indices for each file, but I'm still keeping track of which file the data is coming from so that I can actually assemble it later. This part's fine too, I think. So we're really just doing a histogram and throwing away bins that are too small and truncating bins that are too big. Making another set of parallel arrays. So then at this point we have parallel arrays for the compacted set of grains, so everything that survived that culling process. And then some more parallel arrays that indicate where the bins are in that histogram, since we actually want to save the histogram itself also. So all that I think is fine. Okay, collect audio data though. It's very slow, very memory intensive. The culprit is really this set of kind of monstrous convolution adjacent operations that we're doing here. This was derived from some code that I originally wrote that also would give you a bunch of graphs and plot information about where the grains were, but right, that information isn't even being used. And so fundamentally all this code has to do is throw away audio samples that are too far away from the grain centers that we've identified, and then generate a table that lets me translate the old indices in the old large audio file to indices in the truncated audio file. But yeah, this really needs a different way to work. This is doing a bunch of searches and like it's literally looking for the closest grain for each of these sample offsets. And we have arrays that are already sorted that we could be walking in parallel. I was trying to avoid Python code on the inner loops, you know, of things that could have tens of millions of elements in them in Python. But yeah, I didn't see a great way to do this using just kind of regular numeric Python approaches. But I was noticing in the dependencies when I was setting up like the virtual env dependencies for this, that librosa, the audio analysis library, is already using Numba, which is the JIT compiler for numeric Python, or NumPy. Since we already have that, we might as well just use that to write the inner loop for this thing and not worry about figuring out how to use numeric Python's Legos to build this inner loop. And so if we can just write this in fairly straightforward Python code that's then JIT compiled, that would be kind of handy. I think we could just go through the grains and the samples in parallel and make it order of n. So that's a relatively easy rewrite that'll give us tons more performance for this tool. And this step is kind of slow, just because I think it's actually loading everything into memory, even though theoretically it could be mapping it. I haven't actually checked this, but from the way this is acting, I don't know if mapping arrays that are inside of an NPZ is actually working properly in my version of NumPy. It's acting like the whole array is being actually loaded. Anyway, that's mostly code that is the same from that notebook. It's just here now in a separate little standalone script. This actual thing that writes the output files, though, is all new. Because now we're writing a zip file. This thing with the RVV extension is just a zip. I'm using no compression by default, and I'm using that to write the FLAC file. But then I'm specifically requesting that the index and the grain file are compressed, since they benefit from that a lot. I also tried just giving the sound file module a direct file-like object to write to the zip file. The zip file writers are not seekable, though, even if they're not compressed, because I guess they don't have a special case for that. And in the general case that a zip file member might be compressed, then they're not seekable. Oh, that's a good question. How is it deciding the start and end of each grain? So at this stage, we're not really defining starts and ends, we're defining centers. And it's analyzing the audio file using small overlapping frames, which I think are on the order of like 10 milliseconds right now. And anytime it finds one of those overlapping frames that has the characteristics it's looking for, it saves it to the grain database. So in this case, it's looking for something that has a strong voicing probability, which is how it discerns between stuff that has like a well-defined pitch and stuff that's more like noisy. So it's looking for stuff that has a well-defined pitch within the pitch ranges that it's searching, which are in the order of like 32 hertz to a kilohertz. But beyond that, when the algorithm finds something interesting, it just saves the sample location of that center point. And then during this compaction step, I'm kind of deciding how much of that data to save when I'm making the final compressed archive that'll be used for real-time playback. And I'm picking something. I've been using different numbers for different files here. The default I've got currently is like 3 seconds. And that's distance on either side measured from the center of the grain. So you actually get 6 seconds of audio total, but in a lot of cases also these grains will overlap because you're just looking for any of these matches and you might end up with a bunch of them that are all partially overlapping. So in that case, you might end up throwing away just small numbers of samples or maybe very few samples. You just end up saving a lot of these center locations that you can kind of seek to, but then like pick a window of audio around that. And then the shape and size of that playback window are parameters that you can tweak at real time as you're playing back the audio. The maximum window you can get is limited by this packing step. But if you've saved up to plus or minus 3 seconds of audio, then you can define whatever windowing function you want that's up to that total like 6 seconds of width and use that to modulate how that grain fades in and out. Oh, to go. Maybe I'll switch to the other view. I could use a little more screen space. Okay, so I replace this with performance improvements for compactor, which we could do now or later. And this is important, but I think we do this kind of stuff first. So I already rewrote a format. I think this can get replaced with support for a new format. So. Oh, one little thing we might try is I did manually take the output from the tool in this RVV format and just convert it into the old format. And it might be worth just making sure we can load that just to make sure the tool still works. So this was the original index.json in the zip file. There's the length of the original sound, information on the binned grains. So those are frequencies and grain numbers. But it doesn't have the giant table of sample numbers that identify where the grains actually are, because that is actually kind of large. That's what's in this grains.u64, which you can see is like over 0.5 megabyte already. And then this big old FLAC file. Oh, do I not have... Oh. It's trying really hard to scan for plugins. Don't really need that right now. Oh, there's Audacity. Yeah, okay. This doesn't have a extremely fast importer FLAC. Let's just not do that. It is a modest little 38-hour FLAC file.
Summe einher demnach manchmal unfreigesponnen.
It's only mono at 30 or 24 kilohertz, because that's what the source material was in this case.
Mitgesprochen nebeneinander. Es sich hoch okay mitten gekümmert hat, sich unten herum wettlockert zu Matura ungern miteinander Geschwätze Pudel wohl zustößt gedockt losgeschlagen stehen lässt. Apropos beigekommen gezüngelt geschnappt über Überbevölkerung wohl.
Training.
土田社会民主党交渉議カイロタマティクリティカ
Can please news
Measuring Soviets measuring
on afterwards.
Seiten mitgekämpft.
Some
frame
transfer file with
ムルトインカナキテナダコインコリラメ超総水
Yeah, this is not a small file. It's like 4 gigabytes.
Clamia seemingly redlessness inoculation. No,
baseball keynote grips sir. Shapely strictly
I mean, we can examine some small files too, but they're a lot less interesting. Stuff started to get much more interesting around, I guess, like 5,000 or so of those original files, which would be, what is that, like 1,000 minutes of audio or so? Yeah, kind of the whole gimmick of this particular granular synthesizer toy is that it uses large data sets. Okay, I converted that to the old format by just base64 encoding the grain data and sticking it in here. It's got really long lines, which less is slow with. Anyway, let's just load that. Actually gonna run the GUI thing from a separate terminal. The audio processing thread starts up right away, and then the UI is kind of sluggish.
sometimes
This is the file I had open last time, which is one of the really little ones.
Was into Brook mix into bones enter in some
Try to open the
things these
conversion
nating
one.
she's this never and say parrot living fully unprorable be a poor foul pale sit I'm not ingrid littered and tongues hang
Combine. Does it load?
110
Ooh, it loads. Yes. This one looks a little bit weird because it includes even very underfull bins. So I think here are some spaces where, like, this is a wide range of frequencies with only a couple of grains in it, so the graph looks a little strange. You can also have the packing tool throw away really sparsely populated sections so that the result is a bit more rectangular. Oh, we were hitting that 2 gig issue again.
herumzufliegen, wieder frei gehabt, nirgendwo Szene geplaudert, gemosert so sehr
I also might have got the audio file name for this one wrong. What did I mess up? Sound file, soundlen, NX, grainx. Sound file, grainx. Maybe something else is wrong. Round boy. We don't need to see all this. I missed some obvious errors over here. Oh, I'm also not sure if I'm handling relative paths correctly. I don't know. Let's see if we can figure out where this is breaking.
Summe. Summe einher, demnach
there it
manchmal
is.
unfreigeschwommen, ungelogen wird ringsum her,
I guess I just
drumherum
wasn't hearing it
unisono
before.
11. Meschuge umstößt, expressibelt mitgesprochen nebeneinander, es sich hoch okay mitten
That's less
gekümmert,
confusing.
sich unten herum wettlocker zu Matura ungern miteinander Geschwätze, Pudel wohl zu
Oh, or what? We shouldn't have still been playing the old file, right? Just the file picker doing something complicated. Sure did seem like we got a little bit of audio from this particular file before it seeked. Can we switch files and then switch back without crashing LLDP or anything else? It's a smallish file.
As thou dost it every
This graph is much smoother now that it handles non-uniform axes better.
Granted. Is there
This is from some public domain audiobooks with kind of variable audio quality.
Near no wild beast may scatter it. At that hour were we, all three of us, I like the goat, and like the herdsman they, begirt on this side and on that by rocks.
So here it doesn't even seem to be skipping any audio, which implies that the grains were closer together than 2 seconds.
I beheld the stars more luminous and larger than their
Or
wont,
4 seconds.
thus ruminating and beholding thee.
of paradise?
Malign grandfathers on the even as any made world a new world to grow a new with Herbert be sown with the new one approves.
I see the net that snares you here, why the earth quakes and wherefore ye rejoice. Now who thou wast be pleased that I may
anzureisen, bisschen obendrein teils vorzusorgen, fortlässt gesiegt, gegoogelt, 14
Yeah, okay, this is fine. I was just hitting the 2 gig seek bug.
Gestrampelt, geben Link vor.
Yeah, I can crash it by going right into one of the later parts of the file. Okay. That's about what I expect at this point. I guess the first thing is to actually change the file picker. Not a lot of this code actually cares about the file format right now. It's really just this function. I mean, the part that's actually where it's actually gonna get interesting is when we start trying to run the FLAC reader through the zip layer. Is this read-only? Not that I care for my application. Just often curious what this... Juice is one of those class libraries that, every C++ class library is kind of like its own flavor of kitchen sink. And so you can kind of learn, what they cook in this kitchen. Numeric indices, huh? We can do that. Oh, there's a separate class for writing zip files. Cool. I'm gonna need to keep this around, right? Mm-hmm. I guess that needs to go in the state object that I swap out. Gosh, now that the JSON's a more manageable size, I wonder if I could just store that in here. I kind of like fully dealing with the JSON early, though. It's the kind of function you expect to at least mention some failure modes, right? Let's read the .cpp documentation. I guess this just looks empty if all this fails. Alright, so we won't get super detailed errors, but we'll get something, like I guess we'll have, there's no file and there's nothing inside the zip file, and then kind of we can't really discern on a finer granularity than that. That's alright, I guess. Might be worth checking num entries first. Yeah, I don't know that it's really worth breaking this up beyond, like, we can't find the specific files that we're looking for. Oh, case sensitive by default. I'm gonna need to load the whole grain table into memory pretty much right away. I'm gonna at least defer that until until basically all the format checks are done. So I think I'm gonna have this temporary file reader object that I want to destroy pretty much immediately. I think I'm just gonna have a little local smart pointer to store that. Alright, create stream for entry. Wondering if I need to do that for all the files here. I don't think I need to keep these smaller files around, and I thought the audio format reader maintained its own pointer to an input stream. Is that how this works? I'm using the audio format manager. Can we bypass this format manager and just go directly to FLAC? Yeah, FLAC audio format. Okay. Why is this not static? Why do I need an instance of the FLAC audio format? Is there a benefit to that actually being only created once? That looks pretty inert. I think we just create one of those in the stack. gosh. New state is getting kind of wordy here. don't think we're likely to actually get an error in create string for entry, so I'm going to decide not to distinguish between those and errors in actually reading this into a string. Might just take that directly to JSON and collapse these various errors together. I can just assign a JSON tree, right? It's fine. I guess I could use move. Ah. Hmm. Okay. It's a sensible error. Failed to understand archive, because that isn't even a thing. So now it's looking for that kind of file. Let's try one of these small ones. No, failed to understand. See what that's about. So I don't know how to do casts in OLDB. It's fine, that wasn't very important. Let's look closer at the zip loading. Sure looks empty. Oh, is this still the old source file? Yes, okay. We sure are getting that called twice, huh? 3 times. I guess we don't stop retrying when it fails. me just save this as a new default. Is my rendering thread stuck? One of my background threads is timing out when I'm trying to kill it. I don't know if this is something I want to debug right now, though. Oh my gosh, are we getting... Yeah, actually, maybe this is a problem that would be easier to just fix now. This is having trouble giving up when it fails to load, and so the time slice thread is not dying. It might not even be able to get a new file name at this point. Yeah, I might just need to separately store the last one we tried to load. I don't think I even need the file names in here anymore. I think this will effectively just be some state that's used internally to the time slice thread. That should be better. That wasn't going to be, like, I think a tight CPU burning loop, was it? Because... no, I guess if we're on this path, we would just be burning CPU. If we're on this path, then the thread ends up sleeping most of the time, because I think it only rechecks by default every half a second or something. Yeah, I think that was effectively just burning CPU when the load fails. Which is not great. Okay, right. Oh. Okay, that's failing in the expected way. Let's see if it stays failed. Yeah, it stays failed. Let's try another file in the correct format. Okay. Someday I'll get used to LLDP. Okay, I think this is zip filing it on the one that's failing. Oh, I hope this doesn't just not support 64-bit zip files. I was in this code earlier and it uses fstat for some reason. I cannot understand why they're... I guess fdstat is relatively recent. Maybe there's a portability problem to use that. I don't know, man. It ends up re-resolving the path name every time they check to see whether you're at the end of the file. It kind of sucks. Can't actually call this. Oh, I can. Interesting. Unknown type. I don't think we have symbols for any of these locals. That's fine. So far, this is looking like we should have entries, though, right? There's an element in there. Yeah, maybe I was mistaken, and I was just looking at the entries from the JSON run, and this is actually failing differently. Let's try to figure out where this is failing. Just skip to the end of that for now. 8 entries. Okay. Okay. Oh yeah, actually the software is right. I gave it a file in completely the wrong format. This is the NPZ file. I meant to give it the RVV file. Why did it let me choose this though? Is my file picker broken? My file picker is broken. Okay, well that's confusing and my fault. Is it my fault? Wondering. Oh man, sudden allergies. I'll be right back. I'm wondering if this is just acting weird because the default file has an extension that isn't in the picker right now. Can I just reset my configuration? Let's try that. Oh. Is that not where the... Where is that default? A lot of fonts. Oh, that was not the settings file it's currently using. I changed the name of the app from lowercase to uppercase, and that changed the settings name. Why do we have old copies of this? Okay, yeah, I think that's why the file picker was confused. It has the right extension now. Gosh. That's much less confusing. Still think it's not working, probably for a different reason this time though. We do have an index. hand grains. Ah. 0 is actually valid, so that is my fault. Let's just do this. Someday I'll remember where the pipe is on this weird keyboard. There's a question, am I winning? I don't think any of us are winning, but it would be a nice idea if that were possible, right? I guess in this world, we have a cat that is much bigger than the source code or the humans, and that seems like we're winning. Is it gonna work? Is it gonna work? Whoa, that was fast. Oh, it's coming out the wrong audio device.
Magnificently competent, anaerobically swearing, drunken instrumentation flagrant. Double express outings magnificently comped anaerobically swearing drunken instrumentation flagrant. Lolia brontosauruses barely a lesion. Cleanable express outings magnificently comped Lolia aerobically swearing Lolia double express outings magnificently brontosauruses barely a lesion.
Sonntagabends
It seems to be basically working. That was almost effortless. Let's try a big file.
Inklusive irgendwas mitnichten gleichwohl
I don't have any that are in between 4 gigabytes and 300 or 500K. Let's go right to the 15 gig file here. Loading index. Still a debug build. How long does it take to load the index in a debug build? This may be broken.
Gleichwohl Sonntagabend sinnvollerweise wie wir irgendwas mitnichten gleichwohl Sonntagabends irgendwann bisschen aufzupassen.
Really? This is probably another completely different failure. I totally moved a directory or a file just a second ago. Whatever. Let's try this one.
Summa einher demnach manchen.
Interesting. So that was on the wrong audio device because the change did not save. It was playing until I seeked, presumably past that 2 gig point though. So maybe we have the same bug. It's in one of the layers we didn't change. We can't load more than one of these, huh? Oh, that assertion means somewhere we have a non-UTF-8 string. Are we reading that binary thing as a string? How do I get a nice clean breakpoint on assert? Where's my scroll bar? There it is. That little pixel is my scroll bar.
Nummer einher dem Nachmann.
Wegzusetzen, vorbeizukommen, zugleich gespitzt, gerast.
Apropos beigekommen, gezüngelt,
Somebody thinks we have a very long file name. Could I have tried to open one that is not done writing yet? Frame variable. That's not what I was looking for just now, but I should have been using that earlier, I think. I don't know, if it wasn't done, it would be much smaller than this. You think maybe there's a bug in seeking past 2 gigs at a level underneath the zip maybe, and that's affecting the zip index here? Because if it just seeked into completely the wrong part of the file and then read what it was expecting to be a file name, but it was actually a non-UTF-8 string, that would explain what we're seeing here. Gosh. Let's make sure this is actually what's happening, but so I think we can load some of these successfully and reliably, and then some of these reliably do not load. Maybe just this one. And I would really like to know where it's seeking and where it's reading next. What is that called? Desk. This is going to be really chatty. Okay, here's a small one.
Herumgelaufen, reingeschaut, Ziel unseres
Can we save the audio device setting?
vorbeizukommen, zugleich geschwitzt, gerast.
I think we just exit cleanly once, that'll save this as a default.
Herumgelaufen, reingeschaut, Ziel unseresgleichen hinwegzusetzen, vorbeizukommen, zugleich geschwitzt, gerast. Wegzusetzen, vorbeizukommen, zugleich geschwitzt, gerast.
It says 1 grain in it. It's going to be very confusing. It says 3 grains.
Marine, labored marine, shiftlessness, straddle comical XX, labored contemplatively marine, shiftlessness, straddle labored marine, labored contemplatively coca. Labored marine, labored contemplative marine, shiftlessness, straddle comical XXV.
Okay. Let's not move this. Let's grab the 4 gig one. This is a window size of 1 second. and maximum 128 grains per bin.
Umeinander aufs ausgeweint hingekommen innerhalb pro und weit herum war gefallen in Betreff hinüber.
I think this is the one that's going to be fine until we hit 2 gig in the FLAC file.
Für Modulo getragen.
Yeah. Okay. Next biggest is this one, 5 gig. So nice having a single file at least. Loading the index. There's the crash. The UI is not crashed. Alright, so we're just reading for a while and then detecting the UTF-8 error. The actual bad seek is going to be a while earlier. Probably not that far back, though. It's 839. If we can see which syscalls it's using, we can take a more narrow trace. And let's get a trace in a file.
Herumgelaufen, reingeschaut, unseresgleichen hinwegzusetzen, vorbeizukommen, zugleich geschwitzt, gerast.
Is it going to reliably crash here? Yeah, that's the ominous looking L-seek, isn't it? Somebody's got a 32-bit value in here. I just need to find it. I guess I should make sure that this code is even intended to support 64-bit zips. I haven't looked at that in the zip code. It just seems like maybe there's a problem at the lower level file layers, since I was seeing this via FLAC also, and FLAC is definitely itself designed to support 64-bit files. Yeah, that N32 just finished running. Let's make some more smaller databases. I don't have any that are not either really tiny or gigantic right now in the new format. Let's make kind of a small database that just has a couple of voices. That should be kind of small. This tool is still, as I was saying earlier, way slower than it needs to be. Okay, that one that just finished earlier was this that ended up being 5 gigabytes. Not even that small. Mostly on account of the W5, this parameter is going to make it significantly larger. Oh, Tuco. Gosh, he's been so sweet lately. Okay, let's just look at Seeks.
Herumgelaufen, reingeschaut, unseresgleichen hinwegzusetzen, vorbeizukommen, zugleich geschwitzt, gerast.
Are we using the buffered FLAC reader? Thought we weren't. Buffer is disabled right now. So I think we're just going to be seeking anytime we're playing.
Nabolicbrontosauruses barely anaerobically swearing Nabolic express outings magnificently confident anaerobically swearing drunken instrumentation.
Sich hoch okay mitten gekümmert hat sich unten herum rundherum priebte Sechzehntel gefunkelt hoch oben auf dem zufolge Wechskulen über ein Bäuchling gnädigerweise nachgezählt gut passenden unterm gefunkelt alle Zeit. Niederlangen notfalls herunter einzuloggen 390 vorüberlich anderen rechts herum Gebelsplatten 40 eben darum.
Alright, so we were doing these seeks pretty much exclusively from the very end of the file, getting closer and closer to that 2 gig, and then it rolls over. That's a problem. We need to figure out where that's getting truncated. Let's just see if there's some similar behavior in the larger zip file. Yeah, it feels pretty early there. That's interesting. I'll see. So yeah, this is going to be inconvenience as long as this is happening in the audio thread, but this should run out in just a sec. Okay. I guess I still have the breakpoint in load. Yeah, which hits first anyway. Could have used that to enable. Anyway, I've got a break in an lseek, which should be inside the load. So any of these layers could be messing up our file pointer. Still disturbed by how often this is statting the file. Can I do we have enough debug symbols where I can step through here? Were we out of... Oh, we're out of audio fluid. This is one of those times when it's handy that the streaming itself is happening on a machine that isn't being subjected to whatever we're actually experimenting on. Oops. So far, I think so good. How big is that file actually? Yeah. Could be an interesting. This could be an interesting place for bugs because we're reading at the very end of the file. Maybe reading something where if it was a full length 8K block, it would overlap the end of the file. That all looks extremely reasonable. Completely reasonable so far. What? This is suddenly less reasonable. Is this really an absolute? I'm gonna have to read about how 64-bit zip files work. Maybe this just doesn't actually support them at all. That would kind of suck. I'd just have to find a different zip layer to use, probably. Gosh, okay, maybe this doesn't actually support 64-bit zip. This might be multiple problems. It's possible that, like, it looks like there's maybe supposed to be a compatibility central directory that is below the 2 GB limit, which I don't think we have. Or I guess 4 gig limit. Guess we need to look around and see what libraries we could use for this. And or just write some code. Maybe at least worth checking the repo to see if there's any recent activity in this part of the library. The easiest way to go forward is probably to just like find a different library for reading zip files. It's a little annoying because that probably involves duplicating a little bit of code between that library and juice. Like, I'm probably gonna end up with 2 copies of like, will they both use system as elib? On Windows and Mac, they might end up with 2 copies as elib. I don't know. I don't know if I care. Cast all the values to 32-bit. Yeah, see, something like this might be depressingly convenient. How do you even get a... I'm wondering if there's even a way in Juice to deal with STL strings, or if I have to go through a C string. Hmm. Hmm. Large. Hmm. Oh, my little run here just finished. I have a 300 something meg output. Let's see what that's like. I might check in this since it kind of works, but then I'll have to rewrite the zip layer. I should see how fast this is on a release build. Oh.
Treatment repair and storm comes profitable profitable buggers profitable patients weeds aged singled and related
Gosh, I feel like my default minimum bin size should be greater than 1, because these 1 grain bins are not very good.
Profitable jigs profitable.
That's an easy fix. It seems like a fine default. Let's make some more different sizes. Let's try more grains, but still small grains.
Signalization rearing fixture cowbox centrifuging moded connect skull cap fair canary whales in Sienna pursuers skewering lymphatics aerobatics choirmaster circumlocution king Leus bolt guys ambulanceman brazier zygers and fix ecus huzzing trapezium somoplasms seamlier rhubarb.
It's interesting this 4 gig file loaded. The central directory must have been just barely under the limit. It's weird.
Continued talismans real leaves king liverwood whitish.
Nachts
Loliobrontosaurus, Nabolics, Loliobrontosauropiclesauruses, Nabol express Loliobrontosauruses, Nabol express outings magnificently confid anaerobically swearing drunken in
the marine, labored in the marine, shiftlessness straddle comical XXV labored marine, shiftlessness, straddle comical XXV.
An enthusiastic current burning pavements, broody pecans, it's resharpens, movable.
The graph is a lot less interesting when I only have one voice in the input.
Unnecessarily
this is also very small, like less than 10,000 grains. I should try this with a larger input once I can actually load those.
Slingly tattooing extra mollies is Kuwait Emily. Pressing stay fabric shop. Whoever there's acting and there's lopacy levitate phalanx there's loping soup con Rudy dead substance jump left living peeved anaerobic simple and alphabetized.
Okay. Gosh, well, this might be the best stopping point we find for a minute on this stream. We've technically got this thing loading new file format. It just will probably need some partial rewriting because of the zip layer not doing 64-bit zip at all. It's annoying. Well, cool. I'll keep trying to do this thing where I stream frequently instead of just trying to make each individual stream as long as possible. Let's hang out with Tuco a little bit before we pack this one in. Giant cat. Beans. Should make myself a sandwich and then psych myself up to do some of these dirty jobs between streams. I might just go ahead and do the optimization on that Python code and swap out the zip library. Those are both kind of gross and unsatisfying tasks that kind of need doing if this project is going to work at all. Oh, Tuco, that's getting sharp. It's just kind of satisfying to have a single file with these datasets, though. It's nice to have a single size and name. I think Tuco could do this all night. I might try to keep up like an every other day streaming schedule if we can do that. That way I'm not just producing like way more video than anyone could possibly want, but I'm also not doing something irregular. Well, have a good night. I will see everybody in a couple days.